Hello, today with me, I got my little friend, the Sphero Ball. And the Sphero Ball was our group's robot that we programmed, and the purpose for it was simply entertainment. We built a course for the robot, and it had to go through the course to the finish line. And you can use this robot for entertainment for your dogs or your cats, whatever you have. You could just sit down and program it so it could play and hit courses so your cat or dog can chase it.
So the robot we've chosen for this project is called the Sphero Ball. It is a durable and waterproof robotic ball with an LED panel on top, which will be coding to show you the direction which the ball is going. It is equipped with infrared sensors, a compass, a gyroscope, accelerometer, and it has a top speed of 4.5 miles per hour, which you guys will be seeing when we run it through the obstacle course. The other great thing about this robot is that it's Bluetooth compatible, so you can set it up to your phone, your computer, your tablet, and it also has inductive charging, so we never have to open this thing back up.
Our robot connected via Bluetooth to our MacBook. There was an application that we used to program which has multiple features implemented inside of the app, and all we needed to do from there was input JavaScript codes.
So we use JavaScript as our code, and some of the advantage of the code is that it was pretty easy to understand. Some had English function that's like roll, compass direction, and some I needed to learn provided by the website or the guideline for the robot, such as play matrix animation, which basically gives the LED lights and to show the direction of the arrow as our example. So the code is flexible enough to be adjusted and is able to overcome the maze that was provided. Simply, if we wanted to change the maze, by changing the execution pattern and changing the trajectory, we are able to perform a different type of action. The name of the function that was utilized is common and easy to read and adjust because we are able to identify the specific action at any given time.
Alright, so for the first con I'll be talking about, it's going to be about the how we had to change the robot codes and movements every time we added a new one. So for example, if we had a code at the beginning where we would go straight, and that would be fine, but once we added a code for it to turn right, the straight code would mess up, so we'd have to fix the straight code so that it could all move in one function. The second con now is we had to change the starting position quite a few times, and so basically we would just move the robot like a couple inches apart every time from the starting point, because it wasn't always consistent, and that messed up the coding, so we'd always have to fix that too. And the last con would be just time. We had a lot of trial and error, and that took around like 4 hours plus, so it was very tiring and stressful for all of us to just be working on the robot and doing the exact same thing. Yeah, that's all for me.
On the process of building our robots, there was a few difficulty my group that has experienced. One of them was changing the codes and movements, because every time there was a new code added, the movement and the angle had to be right in order for the robot to function properly. If not, it will keep messing up the robots and it wouldn't be working as we wanted it to. Regarding all this difficulty, my group were able to succeed, overcome all these problems, and succeed on our mission.
So once we realized that was like happening, we added set compass direction so that it can help, calibrate to where the ball was going, and that kind of helped it, but we were still having trouble with it changing because we changed the numbers, but eventually we got it.
I want to die, Dwayne.
So it's interesting looking at a robot. It does seem like it's not the most complicated thing, but there's some definitely difficult tasks that we needed to do with the coding to make this robot go through the maze in the way we want it. So there's 5 factors that we needed to worry about. Of course, there's the initiation compass, there's the speed, direction, duration, and delay time. So I'm gonna tell you guys why they are necessary for this robot to accomplish these tasks. The first one being, of course, the compass. So it needs to know exactly where it is located in its surrounding for us to tell it the direction we want it to go. So when we set the initiation compass, it does a little spin that says, okay, this is north, this is south. Okay, that means now we can navigate it. So, okay, this way is the straight for us that we want you to go, right? So that's where the direction and the initiation compass can technically come integrated. So the third one, which is the speed is not necessarily the most important factor as to how this robot performs its function, but it is crucial when we have that curve towards the end, which is with the increase of speed. That means there's and with no delay time, it allows it to kind of curve in a way that is not necessarily a normal way of turning, right? So, and the delay time, which allowed us to stop the robot at a certain space so it can change the direction without any form of momentum changing the trajectory of the route. So that is pretty much everything. The duration allows it to tell, okay, how many seconds do you want me to perform this task? So each function that you see for each turn, for each straight, there's a code that says, okay, we want you to go at this angle with this speed and at this amount of seconds. That means, okay, we kind of had to do a lot of trials, but there's a lot of resources out there that allowed us to say, okay, this is the kind of function that you need to utilize in a way to perform this task from this robot. So it was a very interesting program. We had accomplished to perform that maze right there.
So overall, the project was actually pretty informative because Sphero EDU, the app, actually came with a bunch of instructional JavaScript lessons that you could take or activities that will show you more of the general basics commands that you could do within Sphero Bolt. And it also gave a lot of links to other people's tutorials within the community, things that people have done themselves using JavaScript. And we were able to look at those lessons and use some of the concepts that they used for our robot. All we had to do is change the conditional labeling as well as the variables to fit our maze specifically. And we did run into a few difficulties in terms of the whole project itself. Our first robot was actually a Mars rover kind of type robot, and that one broke because of some faltering wiring that was provided by Amazon, and it was also missing a bunch of screws. And the second robot that we ended up picking up last minute was all the way in Lacey, and there's only one left, so there was a chance that we weren't going to get that one, and I had to drive all the way to Lacey, Washington before a snowstorm to get that one. And then our last difficulty was not having a meeting area due to the pandemic, so none of us could go to each other's houses, but we managed to find a place called Cafe Noir in Federal Way where we all were able to meet up, and we were able to use their giant meeting room to set up our giant maze, and they were kind enough to let us do that. But overall, the project wasn't too difficult. Everyone managed to do their task, and everyone was able to accomplish what they needed to do on time.
Well, it's been more than 2 hours.
Oh, you know what? That's close enough. That's close enough.